Okay, so this is problem 1.31. And what it asks us to do is to do some vector addition, but doing it using the components. And we're only dealing with vectors A and B, so this is the drawing that's out of your book. It's on page 28. So there are 4 vectors, but they're only asking for vectors A and B. So what we need to do is need to break these up into the components, the vector components. So vector A, which is pointing straight downward, there is no x component, so it's just, and the y component is downward, so it's going to be negative 8.00 j hat, the unit vector in the j direction. We can also write that as 0, negative 8. So from that you can say that A sub x is 0 meters and A sub y is negative 8.00 meters. So those are the components. For vector B, what we're going to do is we're going to create this right triangle. So we're going to break it up into 2 vectors. When added together, result in the original vector. We call this B sub y, and we call this vector B sub x. This angle is 30 degrees with respect to the vertical axis, so this actually is going to be 60 degrees from the fact that this is a 90-degree angle. So 30 plus 60 has to be 90. So to find the components of the B vector, B sub x is going to be equal to B, which is the magnitude. So we're going to say the magnitude of vector B, which is 15, times the cosine of the angle, 60 degrees. So that'll give us that. And it's moving from left to right, so it's positive, so we can leave it positive. So we take 15 meters times the cosine of 60 degrees, and the cosine of 60 degrees is a half. So we get B sub x as the x component. And the y component, do the same thing. We take the magnitude of the B vector, which is still 15, times the sine of 60 degrees, which is equal to the square root of 3 over 2. So 15 times, or we can just put it through the sine of 60 degrees in our calculator, and we get 12.99, so we'll round that up to 13. So that's 13.0 meters. Does that make sense? Because this should be shorter than that, which it is. So that seems to make sense. So those are our 2 components, B sub x and B sub y. And we can actually rewrite the vector B in the other 2 ways that we know. B is equal to 7.5 I plus 13.0 j, or we can write the B vector as 7.5 comma 13.0. So there's really 3 ways we can represent it. We can represent it by magnitude and direction. We can represent it by stating the two components of the vector in the x and y directions, or and then we can do it in the unit vector notation, or we can show it as a vector coordinate pair. And so that's 31. And looking in the book, we get 9. We're answering the right question here. Oh, so those are the components of the vector. Actually, I haven't answered the question yet. So now what we do is we answer the questions. So we have part A is a vector plus the b vector. And the way we do that is we would take the x components, so we can still call this the resultant vector for this operation. So the x component of the resultant vector is the x component of A plus the x component of B. The x component of A is 0 meters. Those are meters. And the x component of B is 7.5 meters. So the resultant vector has an x component of 7.5 meters. In the y direction, we have a sub y plus b sub y. And the y component of the a vector is negative 8.0. And we add that to the y component of the v vector, which is 13. So we get 13 minus 8, that's 5. So r sub y, 5.0 meters. Now once we have the magnitudes of the components of the resultant vector, we can find, so our resultant vector, let's just draw what that looks like. It's 7.5 in the x direction and 5 in the y direction. So it's going to be something like that. And we need to put in our coordinate system so that we have some kind of reference point here. So there's the y-axis and here's the x-axis. So what we have is, this vector is 7.5 comma 5.0. So if we want to find the magnitude of the resultant vector, we just take the square root of the squares of the component. So r sub x was 7.5. And the r sub y was 5.0. So 7.5 squared plus 5 squared. Take the square root of that, and I get 9. So the magnitude of the resultant vector is 9.01 meters, and the angle, we know that the tangent of the angle theta here, which is between the positive x-axis, is going to be equal to r sub y over r sub x. So we get r sub y is 5, r sub x is 7.5. So that's 5 divided by, that's 2/3. So it's 0.66. So theta is the inverse tangent of 0.66. So the inverse tangent of 2/3 is 33.7 degrees counterclockwise from the x-axis. Okay, so that's the answer they're looking for the first part. 9.01 meters, 33 degrees. Okay, so that's the first part. The second part, part B, asks for the vector sum of B and A. So it turns out that it's the same as A, because when I add these vector components together, all I'm doing is switching the order here. I'll have 7.5 plus 0, and I'll have 13 minus 8, and I get the same components. So the answer for part B is the same as A. Okay, for C, I have A minus B. So in that case, what I do is I take the x components of A. So my resultant vector for this part and I'm going to do the components. So the x component of the resultant vector is going to be the x component of vector A minus the x component of vector B. The x component of vector A was 0. The x component of vector B was, what was it? 7.5. So subtract 7.5 meters. So the x component is negative 7.5 meters. And the y component is going to be a sub y minus b sub y. So the for A, the y component is negative something or other. So it's negative 8. So we have negative 8.00, and we subtract v sub y, which is v sub y is positive. Those are both meters. So I get negative 21 meters for r sub y. So if I were to draw that on my diagram over here, I have r sub x is negative and r sub y is even more negative. So it's way down here like that. And let's see if the angle they give is from the x-axis or not. Yes, yes. Okay. So now to answer the question, what is the magnitude of the resultant vector in this case? We do the same thing as we did before. We take the square root of r sub x squared plus r sub y squared. And in this case, r sub x is negative 7.5 meters. Square that, add that to negative 21.0 meters. Square that. So, and when you do that, the final answer is 22.3 meters. The magnitude is always a positive quantity. The angle theta, well, we're going to, well, let me draw it small scale here. So what we had is we had the vector looking something like this, negative 7.5, negative 21. So it's in the third quadrant. So this is the angle we're looking for. So what we can do is we can actually, if we find this angle, we can just add that to 180 to get the final answer. This side is 21, and this side is 7.5. So the angle we're looking for, theta, the tangent of theta is just going to be, and I'm just going to use the positive values. So it's 21 over 7.5. So if you solve for theta, 21. So the inverse tangent, so theta is the inverse tangent of 21 divided by 7.5, and you get 70.3 degrees. So the actual angle, I'll call that alpha. Alpha is equal to 180 plus theta. So we get 180 plus 70.3, which is 250.3 degrees. And we go back and check the answer, and they say it's 250 degrees. Okay, magnitude 22.3, so we're right there. Okay. Now, the order that we add things in doesn't make any difference. When you add vectors, it doesn't make any difference. But when we subtract vectors, like in D, where we do B minus A, again, what we do is we do the x component of the resultant vector, which is going to be b sub x minus a sub x. And b sub x was, oh, what was b sub x? That was, I'm going to go back here. b sub x, 7.5. 7.5 meters minus a sub x, which is 0. So we get that the x component of the resultant vector is 7.5 meters. And then the y component is going to be b sub y minus a sub y. B sub y was plus 13, something like that. Plus 13. And a sub y was negative 8. Okay. 13. So we're going to have 13.0 minus a negative 8 units. So you get positive 21 meters. So in this case, we're actually going into the direction. So here's our coordinate system, and the vector is plus 7.5 plus 21. So this is the resultant vector. So the angle we're looking for here is theta. It's in the first quadrant. So we're going to have, we have r sub x, we have r sub y. So using the pi diagram there, the magnitude of the resultant vector is, again, the square root of r sub x squared plus r sub y squared. R sub x was positive 7.5. Square that. Add that to 21.0 squared, and we get positive 22.3 meters again. So the length of this vector here is the same as the length of this vector there. But you can see that the angle with the tangent of theta is the actual angle. We don't have to add or subtract anything, so it's going to be 21 over 7.5. So r sub y over r sub x. And therefore, theta is equal to the inverse tangent of this. And we already know what this answer is because we just did it previously. The angle was 70.3 degrees. So this is going to be 70.3 degrees, but we don't, since this is the first quadrant, we just use it. So the answer for the last thing is 23.2 and 70.3 degrees. Okay, so that's problem 131.